Today we are on our circle unit, day 2. Our focus is going to be on what we call an arc length. And I hinted to you with a few questions from last night's assignment. We're going to take it a little step further. We're going to look at the following warm-up, and this one was actually similar to what you did in one of the questions last night as well. It says, what length of fencing material is needed? So you've got your pool, and then it says, will be enclosed in a circular fence 4 feet from the pool. What will be the length of fencing material needed? So if you can envision, what we're really doing is we're looking for the fencing for that part right there. So you need to think about, does that imply area or circumference? Well, the distance around would be circumference. So if you take a look, the formula we're using is 2 pi r, or we could use pi times diameter, whichever one you prefer. So up here it says the diameter of the pool is 16 feet, so the diameter of the fence plus 16 plus 4 on each side, so here and here gives me a total diameter of 24. So looks like I'm going to use this formula here, pi times d, and we end up with 24d. Now, if for some reason you wanted to use the radius, we could go and do that. 24 divided by 2 gives me a radius of 12, but again, if you look at your formula, 2 pi times 12, we're going to end up with the same answer of 24 pi. So this first topic, I'm just kind of reiterating what you saw yesterday, and that was the measure of a central angle and its corresponding arc. First of all, the central angle we want to make a note is when your vertex is at the center, is at the circle's center. And its corresponding arc is going to actually equal the central angle. So we're going to put the measure of the central angle is equal to the measure of the corresponding what they call intercepted arc. And I'm going to give you a picture of that. So let's see if I can draw a circle in here. And again, I pick any angle. Notice its center, or its vertex is on the center. If this angle is equal to x degrees, its corresponding arc is also equal to x degrees as well. So let's look at a few examples. We're looking for the measure of arc CFD. So I'm going from C to F to D. So I'm going all the way around here. Well, if you take a look, I have this arc out here is 135. Notice we have a semicircle, which is equivalent to 180. So 180 minus the 135 would give me that arc, which is 45 degrees. Then if you notice, these angles are vertical. So if this arc is 45, its angle is 45, which means this angle is 45, which means this arc up here is 45. If this angle is 81, that lets me know that angle is 81. So to find the measure of that arc in degrees, I'm simply adding all of these values up. And when I added all of those up, I ended up with 265 degrees. And I think my answer is wrong. Let me pause it and double check. Okay, I double checked my answer, I end up with 306 degrees. Let's go to the next one. Notice on this one, we're looking for the measure of angle SPQ. So first of all, if this arc is 86, this angle is 86. If this is 60, its corresponding angle is 60. If that's 154, that means this is 154. So two different ways you could do this. First of all, inside here, all of these angles would have to add up to 360. We can add those up, subtract from 360. Our other option is all the way around here would also have to equal 360. So really the math is going to come out to be the same. I'm adding the sum of those angles that I have, and then I'm going to subtract it from 360, and I end up with a 60 degrees left for, actually both of those. Okay, the last one, I'm looking for WB. Okay, I notice this is 5x plus 10. Notice the markings here. That means this is 5x plus 10 as well. And if you take a look, this angle and this angle are vertical, and I know vertical angles are equal. So we're going to set 12x minus 2 equal to the sum of those. I'm going to go ahead and add those together. I get 10x plus 20. So subtracting the 10 and adding the 2, and eventually end up with x is equal to 11. So I'm going to plug that in here. 12 times 11 minus 2 ends up giving me 130 degrees for this arc or this angle, and notice together those are supplementary. So that ends up meaning that measure is equal to 50 degrees. Okay. Our second topic is what we call, again, we're focusing on the arc length, but in this case we actually want to go and find that length in terms of an actual length measure. So again, let me give you a visual over here. Let's go ahead and draw in a circle if I can. Not very good. Let's suppose I knew the whole circumference of that was equal to 20 pi. But instead, all they wanted me to do was find this arc in here. Well, most of you would say, well, that's half of it, and you get 10 pi. The question is, how do we know, without just visualizing, what that fraction of the circumference is? Well, if you think about all the way around is 360, that shaded part would be 180. So we have 180 out of 360, which ends up giving us 1/2. And 1/2 of that 20 pi gives us to the 10 pi. So let's write that in a little bit more general terms. The length of an arc is the product of the ratio of the degree measure divided by 360 and the circumference. So we have degree out of 360 times 2 pi r. And again, I guess I was trying to let you know that's a degree symbol. Maybe we better write it out. The degree. So if we take a look at this first one, we're looking for A to D to B. Well, the first thing we want to do is find out what that corresponding angle would be. Well, if this is 150, all the way around the circle is 360. We're going to take 360 minus the 150, and we end up with 210. So we want 210 out of 360. That lets us know what fraction of the circumference we want, and we're multiplying it by our circumference, which is 2 times pi. In this case, our radius is 18. So let's talk about how do we simplify this. So first thing I'm noticing, I can cancel these zeros out. Second thing I'm noticing, I have a 36 and a 36. And remember, if you have the same factor in the numerator and denominator, we can cancel those out. And we end up with 21 times 1 pi, which is 21 pi over 1, which is just 21. Alright, let's go take a look at a few other examples. Again, if I wanted the measure of this arc in degrees, it's sitting in front of my face, it's 315. But I want the actual arc length. Notice it's not the whole thing, so again, we're using that formula. 315 over 360 times my circumference, which in this case is 2 pi times 11. I'm not seeing anything right off the top of my head that cancels out. So I'm going to go ahead and multiply straight across. I have 315 times the 22. 360 times 1, and I'm going to go ahead and divide. Maybe it will come out to be a nice integer. Not too bad, 19.25. We could also write that as 19 1/4, or if you wanted to leave it as a improper fraction, we end up with 77 over 4 pi. Any one of those are acceptable answers. Let's go take a look at letter E. Same deal. I want this distance around here. I've got 270 over 360 times 2 pi times 13. Now, some of you are intuitive enough that you might quickly recognize what we're looking for. If we're going this way around, is we are looking for 3/4 of that. Well, let's take a look at how do we get to that 3/4. Well, first of all, the zeros can cancel. 27 divided by 9 would be 3. 36 divided by 9 would be 4. And that's how we're coming up with 3/4. Again, we can multiply straight across. 3 times that 26 gives me 78 pi over 4. Let's go ahead and divide, and I end up with 19.5 pi. Or again, if you want it as a fraction form, 19.5 pi. Okay, last one, same thing. Again, we're looking for that part, which is 150 out of 360 times my circumference. Again, let's cancel these zeros out. 15 and 36. 3 can go into both of those, so 15 divided by 3 is 5. 36 divided by 3 is 12 times 38 pi. If you want to, you can multiply straight across and reduce, or again, I'm going to refresh your memory. Take a look at 38 and 12. They're both even, which means I can divide a 2 out of both of those. So 12 divided by 2 is 6. 38 divided by 2 is 19, and now I can multiply straight across, and we end up with 95 pi over 6. I guess I should be putting some units on all of those. So go back up to what we put down for that formula, because that's going to be the key for you tonight. Here's that formula. Let me bring it all the way down right here. Here's the key formula. Degree over 360 times your circumference, because we are looking for part of the circumference. That corresponds with our arc length. Tonight's assignment is in your packet. It's the very first page. It says Day 2.